Assalamu alaikum. Welcome to another session of data structures and algorithms using C++. My name is Dr. Bilal Wajid, and today we're going to talk about one-dimensional dynamic arrays. So dynamic arrays are different from fixed arrays is that you are able to control the size of the array. Okay, so you're able to ask the user, okay, how many columns do you need? And the user can say I need 10 columns. So, or if the user can say I need 100 columns, or he can say I need 1000. So your program should be able to facilitate the user in fulfilling his or her requirements. So let's consider this. The way you're going to do this is you'll be needing pointers, and you need a new library. And by new library, I literally mean that you need to include the new library. So we need the beloved pointer *p, which can point to an integer type array. This means I'm just asking the user how many columns do you need, where C stores the size of the new column, and then P has been assigned as new integer C. The C here means that, well, this double square brackets show you that it is an array containing C number of elements. Now this particular instruction does three things. Number one, it allocates in the memory enough space to accommodate C integer elements in the array, right? So what that means, well, every element of the type integer requires 4 bytes, so the amount of space needed is C times 4, only because it's an integer type element. The next thing it does, it actually allocates to P the address of the 0th location, or the first element of the array. So consider this. If let's say C is 4, this is our memory. The memory has been allocated or reserved 4 elements stacked on top of one another of the type integer, making this an array of 4 elements. The 0th element's index address is actually assigned to P. So if the address is 0x01, P is now 0x01. And because it's integer variable and every integer variable consumes 4 bytes, we see that from 1 we jump to 5, which is 4 bytes, and then from 5 we jump to 9, which is again 4 bytes, and 9 we jump to 13, which in hexadecimal is actually represented by character D. So A is 10, B is 11, C is 12, and D is 13. So if we, having declared and allocated the requisite space, let's consider initializing our dynamic array. So we can do this fairly easily using a loop where J obviously starts from 0 because that's the 0th index and continues till C minus 1. Remember, for an array of size 4, the index starts from 0 and ends till 3, as has been shown in this diagram on the right hand side. Now the address is actually P plus J, right? Let's see how this works. In the first case, J is of the index 0. P always points to the 0th index, so it always points to the first location. So this is P, and hence this guy, the address plus 0, is actually the same guy. So in the first case, whatever K has been initialized to, the contents of that address are updated to K, and we see, well, the contents of the 0th index have been updated to 11, which was our value K. In the second loop, now J becomes 1, right? Now 1 is, because it's an integer type variable, it's equivalent to 4 bytes. P is 0x01, so P plus 1 is 0x01 plus 4, which is 0x05. So the contents of 0x05 are updated to K because K is the value minus 3. We see that this guy has been updated. Now let's continue the same example and consider the third loop in which J is 2, here K is 5. So J becomes 2, which in byte language is 8 bytes, right? 4 bytes is one integer, so 2 integers later is 8 bytes later. So P is 0x01. So when we add 0x01 with J, which is 8 bytes, the address comes out to be 0x09. So the 0x09's address is the address of location number 2, and we see the contents of 0x09 are updated or have been assigned the value of k. So we see that this location has been updated to value k, right? So that's how you declare and initialize a dynamic one-dimensional pointer. Now let's try this running this code. Remember, I'm using the same function I developed in lecture number 14, only this time, which can print any variable two-dimensional array. And because this particular array that we are talking about has only one row, so we're going to put R as 1, C we're going to remain as is, and P is what we are actually forwarding. So let's try running this code in the terminal. Right, this is the folder which contains all my current lectures, programs corresponding to different lectures. So these are the actual C codes and these are the executable files. So let's just try to compile one. G++ lecture 15.cpp minus output lecture 15. I press enter. You see suddenly this guy appears. It wasn't there a minute ago. And then we just run it, right? Lecture 15. So it's asking for how many columns. I'm going to say, let's say 6, and it says enter numbers till you're done and press enter after each entry. So I'm just going to randomly assign some values, and lo and behold, the same values appear in our matrix: 2, 6, 88, -9, 7, and 5. If we open this code, there's one additional interesting thing here. So that's our include new. This is our function from our previous lecture, and this is what we're doing. So here we declare P to be a dynamic array containing C number of elements and allocate P as the 0th index address. But before returning 0, we also delete this. So by putting this statement, we actually free up the space which we have used in the memory. So I would strongly recommend you do this and not have any dangling pointers left. Dangling pointers is a whole another headache, and I'll probably put another lecture for that, right? So I hope you like the lecture. In the next lecture, we're going to talk about dynamic arrays which are multi-dimensional. I would strongly recommend you subscribe and hit the bell icon so you get notified for new videos. Until next time, bye-bye.